Greetings everybody, this is Henri Batouflet, support engineer at IXBlue. Welcome to this first session of 4 video tutorial on how to prepare, interface and calibrate your INS DVL kit together. I will present you our product or through simulations to explain and detail specific real-life scenarios you have out there in the field. This will allow us to review cool features we have and help you deploy IXBlue systems proficiently. In those 4 sessions, we'll have the first session, which is about unboxing both units and fitting them together mechanically. In a second session, I will use this lab power supply and my computer to configure and quality check my configuration towards the INS DVL calibration. This one I will do in the third video with a mock-up unit and show you the important steps of a DVL calibration. In the last session, I will give you some extra tips and features to help you along the way. Since 30 years, IXBlue manufactures inertial navigation system based on fiber optic gyroscopes, FOG sensors. This technology is robust and maintenance-free, and when coupled to a DVL, offer high performance up to 0.01% of the travel distance in terms of positioning accuracy. For that purpose, IXBlue partners with DVL manufacturers, Doppler velocity log, and offer a set of solutions in which our users are able to choose optimum solutions for their project without compromise on performances. This partnership allows IXBlue to offer you a modular approach with either different grade of units and different grade of DVLs. This gives us up to more than 20 configurations. The INS DVL are typically used in the subsea navigation and position where positioning sensors are not available. Traditionally, we'll see those kits together in an AUV. AUV stands for Autonomous Underwater Vehicle, or in a ROV, which stands for Remotely Operated Vehicle, or on DP structures, which are either platform or big vessels that need to maintain an accurate position at all time to be static. In the DP integration, we'll use our kit in static environment, and the goal is to maintain this very large structure on top of the sea surface while everything could be moving around. Our kit will provide an even better positioning solution because when coupling the INS to the DVL, we'll have a very accurate position feed. On AUVs, we'll use either early bottom tracking or survey grade solution up to 0.01% of the travel distance. The AUV will integrate our OEM product range, which are called the FINS Compact series. They will fly around few hundred meters up to the seabed. While on ROVs, we'll use titanium subsea grade units to go at sea and up to 20 centimeters from the seabed. This is the reason why today I will show you the integration of our ROVs and a Nortec DVL together. I will take those items out of the box and put them on the table. So first, I will take the Nortec DVL. Thanks to our friends at Nortec for lending this nice gear. Then I will take off the box the Rovins Nano. In that box, I also have a specific mechanical interface plate and screws. So for the mechanical interface plate, we can see that we have markings here and there for the INS side and the DVL side. And we also have markings for the alignment pins. So for example, diamond and circle would be for the Pioneer DVL, and the square, the one that we'll look for today, for the Nortec DVL. I have with that 8 screws of a M6 size for the Rovins Nano unit, 4 screws of 1/4 of an inch for the DVL, and a tiny black thing for the cable way that I will fit here later on. At last, I will take off the cable, and I need this special cable which will link the Rovins to the DVL. Now, before assembling this kit together, we'll see that we have two strategies. The first strategy would be to configure one by one those units. It will give me the advantage of maintaining a better tuned settings, more control over the different parameters of each unit, with the inconvenience to be more timely, because I'll configure one by one, then assemble them together. The second strategy would be to connect everything together mechanically and configure everything through the use of the INS. This is the strategy I choose to show you today because it's very fast and very efficient to use. For the mechanical fit, I will have 4 simple steps. The first thing to do will be to connect the cables to the DVL, then to fit the DVL to the plate, then the Rovins to the plate, and then to fix the cable way. So here it is. I will fit the DVL to the plate. For that purpose, I will put this cable way in front of me on the DVL side of the plate. Okay. Then for the DVL, I'll see a little bit more of its feature. I have markings here for an S for serial and E for Ethernet. So this S will allow me to configure serially the unit. I can use some compound 111 grease to have them better ready to go subsea, because today I'm in the lab, I will not use them. So I fit this cable, and also I will fit a plug cable that is in the Nortec DVL box here. So this plug here, just so that when I'm going subsea, I take no risk of damaging the unit. I need to make sure those cables are properly secured, because later on it's going to be very difficult to access them, even though we have a small hole here that allows to connect and unconnect those connectors. Then I will mate the DVL to the alignment pins here and screw it to the plate. For that purpose, I need a small screwdriver here, and I'll use the 1/4 of an inch screw. The idea is to fit already 2 of them, and then I will turn the plate for an easier fit. So I secure the unit with 2 screws here. Here we are. Then I screw it a little bit. And now I can turn the plate very easily to fit the 2 other screws. Once I've screwed them, I use a star pattern to tighten them. And now the DVL is fit to my plate. The second thing I have to do is to make ready the cable way, because after that it will be more difficult to fit this part. So you see on those 2 plastic things, I have one with a notch, so it's the mating one that will go here. It will take my cable here, and later on, only to keep some room to fit the cable on the Rovins Nano, I will fit the second one. Now I just have to fit the Rovins Nano. So I will use the alignment pins here as a reference to find the bolt pattern. And we'll see also on the top of the unit that we have a bunch of interesting markings. One of the markings is giving me the direction to use the product with the front facing forward. And also I have names on the different connectors, so I will use the control connector to configure everything, and the C connector to fit with the DVL. So now it's about fitting those bolts to the plate. While I'm doing that, I will explain to you why I choose purposely not to use alignment pins. For this scenario to be faster and easier to you, I purposely choose not to use alignment pins. That being said, you could have choose to use alignment pins in order to have more mechanical repeatability of your installation. This will be particularly useful should you choose to replace one unit with another in the future and maintain some of the mechanical parameters valid. So then when I'm bolting all those bolts, I use also a star pattern to make the fit easier. I do not tighten the bolts to the end so that then I can press that unit along the XV2 axis, so it's a better mechanical alignment. So now I will push it a little bit against XV2 axis and tighten the bolt using a start pattern. Also, for tightening the bolt, you can use a torque control of 8 Newton per meter. Today, to make it simple, I choose to use the same screwdriver, which is 1/4 of an inch and very close to the M6 pattern of those bolts. So the last thing I have to do is to fit this remaining part, and so I'll pass it through the cable and fit those two missing screws here and use a smaller Allen key to fit them. I don't have to tighten them much. The purpose of this cableway is really much to protect the cable while deployed at subsea environment, so that we do not cut the cable unpurposedly. And before I fit this connector, I really make sure I have an O-ring in place and that it's in a correct use condition. Otherwise, I would have to replace it. Now, to fit this connector, what I have to do is to wiggle it a little bit here and tight to the end the connector. I really need to have a visual check to see a little bit less than 1 millimeter here to be sure it's properly fitted. Now that I've done this, it's time for me to show you my conclusions. For this first part, we've seen that it was very easy to interface together because you basically need those two screwdrivers. It's made simple also with all the markings we have on the plate and the notch and the different aspects. It's a foolproof installation. We've seen that there's many combinations. For example, on this plate only, I could fit a Rovins Nano, a Rovins, an Nortec DVL or a Pioneer DVL. It was very fast to assemble. It took me something like 10 minutes to assemble it together, and then I'll connect to this port and configure everything. This is also the things we'd like to make for you. It's very much easier to configure through the INS with one single connection and more fast. We'll see that in the next video tutorial, how to configure and prepare towards calibration. Thank you for watching this, and see you at the next training video.